morning, everyone. Now, I will tell you in the maths we are going to discuss one topic, and that is rational number. Rational numbers. Many of you have a doubt in the rational numbers. This is a famous topic in the chapter, in the class. You can say 9th and 10th. Rational number means first we should know what are the rational numbers. Rational numbers they follow the category of a real number. First of all, you can say all the rational numbers are real numbers. All the rational numbers are the real numbers. Any number that can be arranged in the form of p upon q. Any number that can be arranged in the form of p upon q is a rational number, but the condition is that q is not equals to 0. Means q should not be equals to 0. That is a rational number. For example, I should give you suppose 2 upon 3 is a rational number. 1 upon 1 you can say all the integers can follow. All the integers you can say are the rational numbers. All the real numbers have both. Real numbers include both. Real numbers you can say real number. Real numbers includes both. They include rational number also. They include irrational number also. They include irrational numbers also. But rational numbers includes all the integers and all the numbers. For example, 5 upon 1 is a rational number. 6 upon 1 this is also rational number. Means it should be it can be arranged in the form of fraction p upon q. And the second condition is that the denominator, that is q, it should not be equal to 0. So this is the example of a rational number. So suppose if we have a minus 3 upon 2, is it a rational number? Yes, it is a rational number, because this is the these should be p and q should be integers. I should say p and q should be integers. All the rational numbers are integers. But can we say all the rational numbers are integers? Minus 3 upon 2, yes. This minus 3 is an integer, 2 is an integer, and the denominator is not zero, so it is a rational number. So basically, these are the rational numbers. Or you can say rational numbers. Another definition is that these are non-terminating or reoccurring numbers. Suppose you have any number. Suppose you have a 10 upon 3, and you are dividing 3 by 10. 3 3 is 9. You are getting 1 point as 0. 3 3 is 9. 1 0 3 3 is 9. Means it is repeating 3 3 3 3. It is going. After decimal 3 is repeating. So it is a non-terminating. It is not ending. It is non-terminating. It is not ending, and it is reoccurring. It means 3 is reoccurring. It is repeating. So it is also falling. This number also falls in the category of a rational number. But there are some categories. For example, root 2, root 3, root 5, pi. These all are irrational number. Irrational number. So why am I telling these are irrational number? Because if we find their values, they are non-terminating and non-terminating, and they do not repeat, and non-recurring number. So this is the little bit of explanation about the rational number and the irrational number. This is a famous question in chapter 9, class 9, chapter 1, rational number. That is, prove root 2 is a irrational number. Irrational number. How can you prove that root 2 is a irrational number? So see the solution. To prove that root 2 is a rational number, first we can prove it by contradiction. First let us assume that root 2 is a rational number. If we are saying root 2 is a rational number, we can say that root 2 can be arranged in the form of p upon q. So we can say that root 2 is equals to a upon b. We can write in the form of a upon b, where b is not equals to 0. Therefore, and you can say a and B, A and B are co-prime. Means they have only one common factor, that is 1. They are co-prime in nature. So when you solve it, you will have a root 2b equals to a. Squaring both the sides, you will have a root 2b whole square is equals to a square. You will have a 2b square is equals to a square. 2 will go into the denominator. B square equals to a square upon 2. Means 2 divides a square. Well, 2 a square divide kara means 2. Therefore, 2 will divide also a. If 2 is dividing a, let us assume for a moment that अगर 2 को divide करते हैं means 2 is a factor of a. So let us assume that a is equals to 2c for a minute, and square both the sides, then you will have a 2 square is equals to, and suppose let us assume a is equals to 2c. Then when again the 2 will go into the denominator, a upon 2 is equals to c. Sorry, a equals to c here. You have let a equals to 2c. We have assumed it. Now put it in this value. Root 2b is equals to a की जगह you will put 2c. Suppose this is the first equation. You are putting the value into the first equation. Squaring both the sides, you will have a 2. B square equals to here you will have a 4 c square. 2 so you will cancel out 2. B square equals to 2 c square. B square upon 2 equals to c square. यहाँ पे हम दे सकते हैं 2 divides b square. Therefore 2 divide b. So you can say that 2 divide b, 2 divide a. So we can say that 2 is a common factor of b. 2 is a common factor of a and b. But we have already decided that a and b are co-prime in nature. Here we have already assumed that a and b are co-prime in nature. If they are co-prime in nature, means this is a statement that is contradictory to our this statement. So hence, what will happen? Root 2 is not rational. Root 2 is a irrational number. Irrational. That's all.